This presentation provides an overview of Chapter 15 in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Iman Hakiki and Thomas Hurdle, and published by Springer. A major advantage of Simple G is that it allows the user to study the impacts of policies across multiple scales, accounting for spatial heterogeneity and identifying spillover effects. In this chapter, we'll demonstrate the importance of this advantage with an example simulating impacts from both global and local drivers of crop price changes using Simple G Brazil. This presentation provides a summary of the study. If you'd like additional information, please refer to Chapter 15 in the book for more details. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover Chapter 15, which is on the role of transportation infrastructure expansion in the transmission of global price shocks to the Brazilian economy. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, discussing the gridded data and parameters, computer implementation, and validation. This application focuses on Brazil and highlights the role of transportation infrastructure in shaping land use decisions. In Brazil, the inland Cerrado biome has experienced rapid growth in crop production since the 1990s, but this region faces much higher inland transportation costs than the more developed Southeast and South regions. The high transportation cost is caused by a less developed infrastructure, in particular the railway network. This negatively affects the competitiveness of crop exports and the profitability of farming. To overcome this challenge, Brazil launched the 2035 National Logistic Plan, or PNL 2035, that aims at improving the connectivity between inland and coastal regions. This study looks at how implementation of the PNL 2035 interacts with a global crop price shock, and how it in turn influences the gridded farm gate crop price, crop output, land use, and the national carbon balance. The model used is called Simple G Brazil, which disaggregates Brazil into 50,598, 5 Arcmin grids, while keeping the rest of world as 16 aggregated regions. Compared with the basic Simple G framework, Simple G Brazil contains a transportation cost module, wherein the national free onboard crop price equals the sum of farm gate crop price and the farm-to-port transportation cost. It also contains an updated cropland supply module that allows users to model conservation policies' impact on preventing cropland expansion and conduct sensitivity analysis. In this study, 3 scenarios of infrastructure expansion are simulated. The business-as-usual scenario assumes no change in infrastructure from the 2017 baseline. The low-level expansion scenario assumes that only the ongoing infrastructure expansions are completed. And the high-level expansion scenario assumes that all planned infrastructure expansions in PNL 2035 are completed. All scenarios include a 10% increase in global crop price as the global shock. Results show that at the national level, crop prices in Brazil increase due to the global shock, but decrease with the reduction in transportation costs. While the global crop price shock itself causes a moderate and uniform increase in farm gate crop price across Brazil, the expansion of the railway network from PNL 2035 further reduces transportation costs in the Cerrado and increases local farm gate price by a much larger magnitude. In view of that, farmers respond to the higher crop price by expanding crop production, which results in a lower national crop price at the supply-demand equilibrium. The impact on farm gate crop prices further influences the production of crops through the extensive and intensive margins. When we only consider the global shock of crop price, states in both the Southeast South and Cerrado regions show low and similar levels of crop output growth and expansions. When the local shocks to transportation costs are considered, though, farmers in the Cerrado biome gain a relative advantage in farming compared with the Southeast South region, which shifts the national crop production patterns. As a result, the crop production, cropland, and non-land inputs use increase much more in the Cerrado biome, while decreasing in the Southeast South region, due to the market-mediated spillover effect. Results also show that the response at the intensive margin is higher than the extensive margin, because non-land inputs have better mobility across regions. Finally, impacts on crop production and land use further influence the carbon balance in Brazil, measured as the net carbon dioxide emission from two sources: the direct emission from the road or railway transportation of crops, and the indirect emission from the loss in carbon stock due to cropland expansion. Under the business-as-usual scenario, the increase in global crop price triggers cropland expansion and the associated terrestrial carbon emissions in all regions. The spillover effect of cropland demand, however, causes emissions to increase in the Cerrado, but decrease in the Southeast South region. Furthermore, the expansion of the railway network leads to the shift of transportation modes from road to the more carbon-efficient railway, serving to reduce transport emissions. The national net emissions therefore decrease with the expansion of infrastructure network. The takeaway message is that it's important to incorporate the spatial heterogeneity in shocks and spillover effects in gridded analyses, thereby allowing for a more comprehensive evaluation of policy impacts. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 15. We encourage you to explore the other companion videos that accompany the book on the Simple G webpage.